Hi, welcome to today's lesson. I'm Emmanuel. In this video, I'm going to be taking you through the process of rationalizing surds. Now, the question you are going to be asking me is, why exactly do we need to rationalize? And what is rationalization? Now, remember that surds are the square roots of irrational numbers. That is, numbers which do not have exact roots. But there is a small problem with surds. And that problem is the fact that surds do not exist at the denominator level. As a matter of fact, it is a crime to leave surds at the denominator level. Now, let me show you an example. Look at the square root of 3. Okay? 3 in the root form cannot necessarily be simplified. So you can leave your answer as root 3. Also, you can write root 3 over 1, which is the same thing as root 3. You could also write root 3 over 2. It is allowed this way, as long as the surd is at the numerator and the surd cannot be simplified. You can leave your answer this way. But there is a small problem. Let me show you an example. 1 over root 3. In this case, the surd is at the denominator. Alright? This is a crime in mathematics. You do not leave your surds at the denominator. You have to find a way to remove the surd from the denominator. And that is exactly the process of rationalization. So again, rationalization is the process of eliminating the surd from the denominator level. Now let us rationalize this number. 1 over root 3. To rationalize, you look at the surd at the denominator level. Identify the surd. The surd is root 3. Now multiply both the numerator and the denominator by that particular surd. So we have 1 over root 3 multiplied by the surd identified at the denominator level is root 3. So 1 over root 3 multiplied by root 3 over root 3. I'll take you through it again. Identify the surd at the denominator level. Multiply both the numerator and the denominator by that identified surd. So you have 1 over root 3. Root 3 is the surd identified multiplied by root 3 over root 3. Now, the exact reason why we are taking this process is because we understand from our knowledge of mathematics that when we are multiplying a surd by itself, we are going to eliminate the surd that way. Look at root 3. Root 3 times root 3 is root 9. Root 9 becomes a perfect square, which has an exact root. So by multiplying root 3 by root 3, I'm going to get root 9, which will give me an exact root, thereby eliminating the surd. So my final answer will be 1 times root 3 over root 3 times root 3 times root 3, which would be root 3 over root 3 times root 3 would become root 3 times 3. Okay, so I'm going to have root 3 over root 3 times 3 is root 9. Okay, the square root of 9 is 3. So I have root 3 over 3. And that eliminates the surd from the denominator level. Okay, one more example before we go. We have example 2, rationalize 3 over 2 root 7. Okay, now the first problem we have here is that root 7 is a surd at the denominator level. So we need to get rid of root 7. So we say 3 over 2 root 7. The surd identified is root 7. So I'm going to multiply both the numerator and the denominator by that surd. So I'm going to have times root 7 over root 7. Okay? 3 times root 7 will be 3 root 7 over. Now look at this. I have 2 root 7 times root 7. 2 root 7 times root 7. So I have 3 root 7 over, now pay attention, I have 2 root 7. 2 root 7 itself is 2 times root 7. So 2 times root 7, then another root 7 times root 7. So I have 3 root 7 over, remember, root 7 times root 7 will be root 7 times 7. And I have 2 here. So I have 2 times root 7 times 7. Okay, so I have 3 root 7 over 2 times root 7 times 7 is root 49. And the square root of 49 is 7. So I have 3 root 7 over 2 times 7. So my final answer will be 3 root 7 over 14. Now if you look at this, 14 is at the denominator. The surd has been successfully eliminated.